What is a geometric sequence? According to Beth's research, a geometric sequence is a special type of sequence. It is a sequence in which every term, except the first term, is multiplied by a constant number to get its next term. To get the next term in the geometric sequence, we have to multiply it with a fixed term, known as the common ratio. And to find the preceding term in the sequence, we just have to divide the term by the same common ratio.
What is finite sequence? A sequence is finite if it has a limited number of terms and infinite if it does not. Finite sequence 4, 8, 12, 16 to 64. The first of the sequence is 4 and the last term is 64. Since the sequence has a last term, it is a finite sequence.
An infinite geometric sequence is a geometric sequence that contains an infinite number of terms, i.e., its last term is not defined. For example, 2, -4, 8, -16 is an infinite sequence where the last term is not defined.
One of the most famous examples of geometric sequence concerns the invention of chess. According to a legend, Grand Vizier Sisa Ben Dahir invented the game of chess and gifted the Indian king Shane with a chessboard. Most many of the main reasons why Beth took interest in the geometric sequence.
Here is an example of a geometric sequence: 3, 6, 12, 24, 48, with a common ratio of 2. The common ratio of a geometric sequence can be either negative or positive, but it cannot be zero. Here we learn the following geometric sequence formulas: the n term of a geometric sequence, the recursive formula of a geometric sequence, the sum of a finite geometric sequence, the sum of an infinite geometric sequence.
Let's have the samples questions. Find the sum of an infinite geometric sequence whose first terms is 5 and common ratio is 1/4.
After we substitute is when we start to solve for the sum. Calculate the common ratio, raise to the power of n, subtract the resultant Rn from 1, divide the resultant by 1 minus r, multiply the resultant by the first term a sub 1, and that's how we found the sum.
Now let's try to solve a finite sequence. Find the sum of the finite geometric series 5, positive 10, positive 20, and up to positive 5,120. The solution goes: as the common ratio is 2 and a sub 1 is 5, the nth term of the sequence of terms can be written as a sub n equals 5 multiplied by 2 and n minus 1. To find the number of terms of n, substitute 5,120 for an. Thus, 5,120 equals 5 multiplied by 2 and n raised minus 1. Thus, 1,024 equals 2n raised minus 1. 2 raised to 10 equals 2n minus 1. 10 equals the n term and minus 1. N equals 11. We divide both sides by 5 and apply the equivalent property of exponential expressions. N is equivalent to 11 because the sequence has 11 terms. With a sub 1 equals 5, ratio equals 2, and nth term as 11, we have Sn equals a sub 1 multiplied to 1 and minus the ratio raised to n over 1 minus r. And this equivalents to 5 multiplied by 1 minus 2 raised to 11 and over 1 minus 2, that is equivalent to 10,235.
But what exactly are the key difference between finite and infinite sequence?
Well, it's quite simple. A finite sequence has starting number, a difference or factor, and a fixed total number of terms. Infinite sequences don't have a fixed number of terms, and their terms can grow to infinity, decrease to zero, or approach a fixed value. The corresponding series can also have an infinite, zero, or fixed result.
That's all for our mathematics performance task. Thank you for tuning into Beth Harmon figuring all about the geometric sequence.